Hello, welcome to Econometrics Melody. In this video, we'll discuss about the random variable. So let us perform a random experiment, and the variable originating out of random experiment is called as the random variable. So we are tossing two coins, and tossing two coins is equivalent to tossing a single coin twice. So these are the list of all the possible events, and then up to this point we don't have any variable in existence. We simply have the list of all the possible events. And in our earlier videos, we have already seen on how to calculate their probabilities. So let us create a variable. Out of these events, let us concentrate and count on the number of hits. And let us name that variable age x. So we can name it by any name. And the random variable originates from this point onward. And the variable is going to take some value. So in this case, they are going to take the discrete value because our random variable, that is the number of hits. So for this example, the value ranges between 0 to 2, and they are discrete values, meaning thereby the value can range from positive to negative integers or the counting numbers. So here it is positive counting numbers including 0. This is called as the discrete random variable. So in some cases, the random variables, that is the variable constructed out of certain random experiment, can take the real numbers as their value. Therefore, such variables are called as continuous random variable, which we'll explore later. Now let us focus on this, and let us draw a neat table out of it. So we have our random variable, we named it x, and the respective values of the random variable, we have also accounted for their frequency as well as their probability, and this probability is nothing but the frequency divided by the total number of the sample space, or the total number of the frequency. We get their respective probability, and similarly we have also calculated their cumulative frequency. We have simply added their frequency in a progressive way. We get this result, and similarly the cumulative probability as well, and they are expressing the same thing in two different ways. Now if we plot the random variable on x-axis and either frequency or probability on the y-axis, then we get the probability mass function for the discrete random variable, so which is clear in this graph. When the value of random variable 0, we have the frequency as 1, and when it is 1, the frequency is 2. And so these bar graphs, they are representing the probability mass function. So for the continuous random variable, the same will be termed as the probability density function, and in that case we will not have a bar graph, rather we will have a continuous graph. On the other hand, if we plot the values of x random variables on x-axis and the value of cumulative frequency on the y-axis, then the nature of the graph, this is of this ladder nature, and this is called as the cumulative density function. So the CDF graph for the discrete variable is of the shape of the ladder, the ascending or upward ladder, while for the continuous random variable, the CDF is something like this, like the yes. So this is the basic concept of the random variable. When we perform a random experiment, and based on the possible outcomes, all the possible outcomes of that random experiment, we construct a variable that is going to take certain values, and we assign the frequency, or we calculate the probability, and we plot the graph. So if we plot frequency or probability against the random variable, then we get the probability mass function for the discrete random variable, and we get the probability density function for the continuous random variable. And if we plot the cumulative probability against the random variable, then we get the cumulative density function. Let us reinforce this concept by other examples as well. And let us come to the example of a random experiment of rolling two dice. On the extreme left, we see possibilities of all the outcomes, or all the events. So these are the list of all the events, and this is equivalent to naming the position of the elements into 6x6 matrix. So up to this point, we don't have any random variable. And let us say if we want to sum the numbers appearing in two die, then that is a random variable. Otherwise, if we don't focus on sum, and if we want to calculate the product of the numbers appearing in the two dice, then that is also the case of the random variable. Now let us focus on the sum of the numbers appearing when we roll two dice. So this provides the list of possible sums of the numbers when we roll two dice. The minimum is 2 and the maximum is 12, and their respective frequency and their respective cumulative frequency as well as their probability. And from the cumulative frequency, we can calculate the cumulative probability as well. On the extreme left, we see that when we plot the frequency against this random variable, then we see this graph. The random variable is the discrete random variable because the values it takes is the counting numbers. We don't have any decimal numbers here, so such variable is called as a discrete random variable. And if we draw the frequency against the random variable, generally the frequency they are in the form of bar graph, so this is called as the probability mass function. And if we draw the graph of the cumulative frequency against this random variable, then the figure that we are going to get is called as the cumulative density function. Let us see it in the graph as well. And for the continuous variables, so if we look at this particular graph, we see that the bar graph, it represents the probability mass function because it is a discrete random variable. And had this been a continuous random variable, then there would be no breakpoint at the graph. It will be continuous, represented by this normal curve. So our random variable x, and it represents the sum of the numbers that appears when we roll two dice. And in our x-axis we have our random variable, and in our y-axis we have the frequency, or we can plot the probability as well. So this figure, it represents the probability mass function because our random variable, it is our discrete random variable. So the probability of getting sum is 2 is equals to 1 by 36. So had this been the continuous random variable, meaning thereby the random variable could take any real number values, then this would be a very continuous line represented by this white line. So this resembles to the normal distribution, and our normal distribution is actually a continuous random variable. And when we plot the cumulative frequency against, or the cumulative probability against the random variable, then we get the cumulative distributive function. And the nature of the graph is of this ascending ladder, then we call it is the cumulative distributive function of the discrete random variable. And let's say the probability between this 2 and 3 is equivalent to the probability of 2, and probability between 5 and 6 is equivalent to the probability of 5. That is why the every succeeding line, before the every succeeding line, we have this line connecting. And had this been a continuous variable, then in that case cumulative distribution function, it would have been a continuous line represented by this S kind of shape. Now let us see some of the features of the discrete random variables and the continuous random variable. So we have, it is some sort of review. Actually, we have already said that the random variable with values is plus or positive or negative of the counting numbers, or the integers, positive or negative integers including 0. If the random variable is going to take this value, then it is called as the discrete random variable. While the continuous random variable, it takes the values as real numbers and within an interval. And the CDF of the discrete random variable is calculated by summing the probabilities up to the point x is less than or equal to a, that is equal to the CDF of random variable for point A. Is, for example, so what is the probability of getting less than or equal to 3? This is represented by capital F3, and we calculate it by adding the probability of the values from 1 to 3. We assume that the minimum value the random variable is taking is 1. Otherwise, we could have calculated the sum beginning from that minimum value, whatever minimum value it takes. Another example, so how do we calculate the probability of x is greater than 3 and less than or equal to 6? So we calculate it by taking the CDF when the value of x is less than or equal to 6, and the CDF when the value is less than or equal to 3, and this is self-explanatory. So the capital F, it represents the cumulative distributive function. Similarly, let us come to the continuous random variable. So in continuous random variable, the probability density function is given by fx. We know this function, and by the help of this function we integrate. Integrating is equivalent to adding. In our discrete random variable also, we calculate the CDF by addition of the individual probabilities, and this is equivalent to it. So in our continuous random variable, we calculate the probability for a certain interval, and this lower L represents for the lower bound and U represents for the upper bound. So the lower bound and upper bound are the limits of this distribution. So any numbers away from this limit, then our probability is equal to 0 in that case. So when we integrate from the lower limit to the upper limit, we get the probability is 1. This is equivalent to summing the probability of all the possible outcomes. Now if we want to calculate the probability from interval A to B, let us say that lies within the limit of this lower and upper bound, then this is equivalent to adding, integrating, we are adding the probabilities from the point A to B. This is equivalent to the probability of x greater than equal to A and less than equal to B. So unlike the discrete random variable, the probability at a particular point is 0 in case of the continuous random variable, and in order to calculate the probability of x is less than equal to A, we simply integrate it from the lower bound to that point A. So for the clear understanding of the probability mass function or PDF of this discrete random variable and continuous random variable, as well as the nature of their CDF, please refer to our earlier videos. We have already covered the probability mass function of the discrete random variables in the topic called binomial distribution, hypergeometric distribution, and Postmark distribution. Similarly, the PDF as well as the CDF, the nature of the graph, we have covered the normal distribution, T distribution, and chi-square distribution, F distribution. So please refer to those videos. So this is it for this tutorial. Thank you very much for your time. Thank you very much. Econometrics Melody.